Assalamualaikum to all the judges and a very good morning. My name is Hasifa. For today's presentation, I'm going to present my research finding where I'm looking at the ground level ozone fluctuation characteristic within two industrial areas in Malaysia. Together with other researchers, Dr. Narimi Rosaida, Dr. Muhammad Faiz Muhammad Amin, and our student, Nur Fatihana Muhammad Junaidi, we are all from Faculty of Earth Science, UMK Chile campus. I might having a sore throat, a bit of difficulty of breathing, and sore eyes. These are the effect of the poor air quality where I live. What is poor air quality? It is the air that we breathe in that might be contaminated with some of the air pollutants. One of it is ozone. Ozone pollution is the second most significant prominent air pollution in Malaysia. Ozone becomes harmful at the ground level as it unstable and very reactive oxidant that can deposit into more surface, including our biological tissues, for example, in lungs, eyes, and plants. Whereas ozone is produced by its precursor, means by the anthropogenic emissions or natural emissions, both from nitrate oxide, NO, and NO2. The lifetime of this precursor, the rate of their reaction in the atmosphere, and the lifetime of ozone itself in the ground level ozone combined make the ground level ozone a regional global scale problem. Means that from the local ozone pollution, it can transport to the other region, other continental, and become a global scale problems. There's a few issues that are relevant to be discussed and has led to this research. One is the location of the Malaysia. Malaysia is known to be the tropical countries where ozone fluctuation concentration are caused by the anthropogenic and natural emissions. For example, because of these different land use settings by the elevated levels of anthropogenic and natural emissions, that is important to understand the ozone and its precursor using diurnal variation of ozone in daytime and nighttime. One of the example different ozone variation that has been studied by Negarabanan, showing that the ozone concentration is higher in suburban than in urban. Whereas the report from DOE has reported some of urban and rural recorded higher level due to the NOx and VOC emitted from vehicles and industries. Many case studies that relate to ground level ozone pollution with air quality using diurnal variation. Diurnal variation is the most common to show the linkage of the ozone formation and destruction with its precursor. With this approach, the fluctuational characteristic of ozone have been identified in different land use settings. As for example, urban is the most common air pollution where the trends of ozone concentration exceed the recommended Malaysian ambient air quality guideline during the noon, and the concentration is actually depending on the precursor, the number of vehicle, and the meteorological factors. Furthermore, nowadays the diurnal variation have been and continue to be assessed due to the formation of the photochemical reaction between primary precursor. There is an urgent need for us to explore the behavior and the characteristic of ozone formation in the fluctuational variation using diurnal plot. Here is the two research questions that need to be answered. One is the characteristic of ozone fluctuational, whether it's exceed or not. So we use the diurnal variation to show the ozone concentration fluctuational. And then the second one is what is the actual time period for ozone start to increase at the urban, suburban, industrial? Is there any difference? So that leads to this first and the second objective. Numerous examples of ozone concentration using diurnal plots are available in the literature. This popular method to show the variation of ozone concentration have been explored and introduced as CCP by Awang et al. In 2015. What is CCP? CCP is to the extent when the NO2 photolysis rate begin to exceed the NO titration rate during the morning, which correlate to the positive ozone formation production rates. So the CCP show the exact time of the ozone start to positive. So there is an urgent need to explore the time range, which is we introduced in this study as a CTT, the new information. The CCT is defined as the time range of each CCP before the O3 ozone reach its peak level, where it includes the starting point of the CCP, where O3 start to produce until it reach the highest peak level that would call the CTT. We use using diurnal plots. So here is the framework to achieve the research objective. There are two sections. The first one is the secondary data, and the second section is the primary. The secondary data we use is 12 years data to find the CCP, the CCT, and the CTT, whereas the primary data is to comply the secondary data and monitoring the existing environment by supporting the evidence and discuss of the results of the secondary data we use the PCA analysis. Thus, the contribution for this research is where CTT are important period in O3 daily fluctuation that should be given more attention to understand the O3 formation. Here is the study area. The secondary data, the 12 years data, is the continuous air quality monitoring station by the DOE, and our study site, our monitoring site is 1 kilometer away, plus minus 1 kilometer away from the continuous monitoring site of DOE. The red one is our monitoring site, and the blue one is the monitoring site of by DOE. Here is in Baka Arang and here is in Shah Alam. So the diurnal variation of O3 in Shah Alam and in Baka Arang, the results show that it has the unimodal shape. But then there is a large difference in the frequency of total daily maximum of ozone concentration between these two locations, even they are from the same land use type, industrial. So we use to show the CCP. The results of Shah Alam ozone start to rise around 10 a.m. and the highest rate of NO2 photolysis is around 11 a.m. and the point of the intersection of NO2 with the ozone, we call it the CCP. The point here is the CCP, and CCP indicate the time. So whereas in Shah Alam, in Baka Arang, the CCP is a bit earlier. The NO2 decrease and the O3 ozone start to increase. The interception is here at 8:30. Okay, so we go to the next objective to find and to investigate the critical transformation time, the new information, which is the period of ozone start to positive production rate until its peak level. So we use the 12 years data. Here is the results from 2000 to 2011, the 12 years data. The CTT in Shah Alam is range around 10 to 11, and the in industrial suburban is bit earlier, 9 to 10. This is supporting we can use PCA analysis to support why the Shah Alam a bit later and why Baka Arang is a bit earlier. Here is the 10 significant parameter when we conduct the PCA analysis. There's a 10 parameter in the factor loading for explain the data that influence the ozone fluctuation in Shah Alam, whereas in Baka Arang there's only 1, 2, 3, 4, 5 parameters that influence the Baka Arang fluctuation of ozone. So we can conclude that this study can expand our understanding of the use of critical transformation time in ozone formation in daytime. So it could show that the commercial industrial area in Shah Alam emits more oxide than in Baka Arang. These two main precursors has contributed to the time of ozone formation, the CT and the CTT. CTT could be used in ground level ozone prediction as it represents the crucial time range of ozone formation. That's all. This is the references, and I would like to thank the grant funded under SGJP and express the gratitude to Department of Environment to allow the use of their data to carry out this research, and the Ministry of Education as well as UMK for the research funding. With that, thank you.